Now we're going to look at the unit circle, and it does have a relationship to the trig. The equation of a circle of radius 1 and center the origin is x squared plus y squared equals 1. You've already done all this kinds of stuff to know about circles. So what we want to look at here is first a little bit about what kind of points do we have on the unit circle. Suppose we have x equal to 0.5. Let's find y. What y value on the unit circle would give us that particular point? So if I let x equal 0.5, I square it, and I want to solve for y. So y squared would equal 1 minus, and 0.5 squared is 0.25, which would give us 0.75. Now that's y squared. And if I take the square root of that, I have two values. And on a calculator, you'd probably chop it off like at 0.866. That can be a problem, though. If you chop it off and then you put it back up in here to test it, you don't quite get the right number. Let's take this y value and put it back up in here. See what we get. If I put in 0.866 and square it, does it equal 1? Well, when you square it and you add them together, what you actually get is 0.9999, I think maybe 56. It's not exactly 1, but it's pretty close. So when you use the calculator with some of these problems, and you're going to use decimals, I know you are, be sure to put in lots of decimal places. I would say this might be enough, but you might want to do maybe 6 decimal places just to be the most accurate way you can. Now let's go back and see what happens if you don't actually put in your decimal. We had y squared as 70.75, so y is the square root of 0.75. And when I square it, I get 0.75. I get the square root squared is 0.75, and 0.5 squared is 0.25, and they add up exactly to 1. So if you can keep it not using decimals, you're going to end up having to do that anyway with some of your problems. Let's think about that y squared being equal to 0.75, which is 3/4. If y squared is 3/4, to get y, I have to take the square root of both sides, square root of 3/4. And you will see a lot of these, so you'll get more accustomed to it. If I take the square root of the top, I get the square root of 3. If I take the square root of 4, I get 2. So it's not under the radical, and this will be a number that will be familiar to you in trig, I hope. So this is one of the things that you can do as far as solving to find y. How about, let's look at another point. Let's look at x equal to 1/2 and y equal to 1/2. And I'm going to look at these in fractions instead of the 0.5 like I just did. If I take this, I want to know, is this point on the circle, on the unit circle? Well, x is 1/2 and y is 1/2. It should be 1/2 and 1/2 is 1. But remember, the unit circle is you square each piece. And if I square 1/2 and square 1/2, square of 1/2 is 1/4. So I have 1/4 plus 1/4, and that is not equal to 1. This point is not on the unit circle. If you think about the unit circle, and you see it in the lesson, so be sure and check that out. The unit circle means my radius is 1, so I have a 1 here, distance, so that would be the point 1, 0. And if I look at the point x equal to 1/2 and y equal to 1/2, well, this is 0, 1, because my 1 is up here. This is the point. The 0.1/2 is inside the circle. It's not on the unit circle. So if you ever need to know if a point is on the unit circle, you put it into this equation, x squared plus y squared equals 1, which we'll be doing a lot with. But just be sure to test your values, and that's how you'll know if it's on the circle. Now we're still with our unit circle, but we want to talk about radian measure. What is radian measure? Well, we know that the radius of the unit circle is 1, but radian measure really goes with any circle. And this is our radius right here. So this length right here is 1 radius. What I have up here, this arc length, the arc that I drew has a length equal to 1 radius. So I just took the radius, laid it out on the circle, and I have 1 radius. The angle measure that I have inside here, this angle measure, is called 1 radian. So that's what a radian is. It is the angle, that's the size of your radius. And it can be a radius of 1 or 2 or 5 or any 1.2. But the arc length measured off the same as the radius has the angle inside that is 1 radian. So suppose that I want to go 1/4 around this 1/4 of the circle. What is the angle in radians? Let me back up a little bit first. I need to talk about going all the way around the circle. We know that there is a 360-degree rotation in a whole circle. That's 1 complete rotation of the circle, or revolution. That is also 2 pi is also the rotation in radians. All the way around the circle is 2 pi. If you take your radius and you lay it around the circle, 1, 2, 3, 4, 5, it's about 6. 2 times pi is about 6.283, something like that. So 360 degrees of angle is the same as 2 pi in radians, and it's 1 circle no matter what the radius is. Okay? So if we were going to go 1/4 around, so I'm going to start at my 3 o'clock position or the positive x-axis, and I want to go 1/4 of the way around the circle. If I wanted in radian measure, which is this section, I would have to go 1/4 of 2 pi. 2 pi radians is all the way. 1/4 of that would be 2/4 or pi over 2, 1/2 radians. So 1/4 of the circle would be pi over 2 radians. So if I look back up here, 1/4 of the circle gets me there, 1, 2, 3, 4. So this angle, complete angle up here, the whole first quadrant angle would be pi over 2 radians. Well, suppose I have an angle that is 7 pi over 6 radians. I want to know where that is. Well, 7 pi over 6, 7/6 is greater than 1 pi, because 1 pi would be 6/6. So if I go 1/2 pi to here, that same distance again would mean I have pi radians there. This is a little bit bigger. It is 1/6 bigger, so it would be down here. So that gives me an idea of where it would be. What part of the circle is that? What fraction of the circle is it? Okay, well, if it's 7 pi over 6, And I want to know what fraction of the circle. The whole circle is 2 pi. So I would divide that by 2 pi. Okay? Dividing that by 2 pi means the pi's are going to cancel because I have one on top and one on the bottom. And so if I have 7/6 divided by 2, 2 over 1 is 7/6 times a half is 7/12 of the circle. So 7/12, 6/12 would be half. It's a little more than half. So there are various ways you can think about how much of the circle, how far around you go in radian measure, what fraction of the circle here, or where it lies on the circle. So we're going to look at some examples now, an application or two about this. So in this problem, you're walking around a lake, and we will assume it's circular, even though that's not very likely that a natural lake is completely circular. But you've walked 4 miles around the outside of this lake. Starting at that 3 o'clock position, positive x-axis gives you a visual of where to start. Start here and walk around. The radius of the lake is 1 mile. So our question is, what is the angle of your final position? So we've started to walk around the lake, starting here, and you're walking around the lake that way, and you've walked 4 miles of a lake whose radius is 1 mile. So if the 1 mile is 1 radius, okay? So if you've got 1 radius and you walk 1 mile, you've walked 1 radius, okay? But we walked 4 miles. Well, then that must be 4 radius lengths. Well, remember what a radius length is? A radius length is a radian. So the angle is 4 radians. That is your angle. Just 4, not 4 pi, 4 radians, just an integer value. Well, that's great. But where on the lake is that? It'd be nice to know if there's a sudden thunderstorm coming. Do you go back? Do you go forward? Well, 4 miles around, how far is all the way? All the way is 2 pi radians. That's a complete revolution or rotation. The complete circle is 2 pi radians. 2 times pi is about 6.83, let's say about 6. So if I walked 4 radians and all the way around is 6 point something radians, I've gone about 2/3 of the way around the circle. 2/3 around. So since that's over half, to get back to start quicker, you keep going. So 4, 1, 2, 3, 4 is down here somewhere. Oh, that might be about 2/3 of the circle. So it'd be better to keep going. Basically, I'm over half, so then I want to keep going. Let's make it a little more complicated. Instead of a radius of 1 mile, let's make it a radius of 3 miles. Right here. I'm still going to walk 4 miles. My radius now, though, is 3 miles. So this is a 3-mile radius. Well, if 3 miles is 1 radius and I'm only walking 4 miles, I haven't really gotten very far beyond 1 radius. So what I've walked is 4/3 radians. I've taken my 3-mile radius. So 3 miles is 1 radian, and I've only gone 4, which is just a third more. So it's 4/3 radians, or 1.33 continuing. So that is my angle that I have walked around, is, in this case, not this far down, but just a little bit over my 3, maybe up here. So what part of a circle is that? well, let's see, if I've gone about 1.33 radians and there's about 6 point something radians for all the way around, I've gone about 1/6. Very loosely fractions, just about 1/6 of the way around, not very far at all. So I've walked the same distance, but this is a bigger lake. It's got a bigger radius, so it's a bigger lake. Okay, let's complicate this even further. Suppose, that's my question. I don't want to know the angle of the final position. I want to know how far you walked. So let's say, starting at the 3 o'clock position, we're walking around a lake. The radius of the lake is 5/4 miles. Okay? The radius is 5/4 miles, and we walked to an angle of 120 degrees from start. 120 degrees from start. What's that look like? Start over here. We've seen recently that up to here, well, you know, up to there's 90-degree angle. Boy, that's not 90 degrees, is it? Let's try to do that here. There we go. And I've gone 120, so that's another 30 degrees, so I've actually walked over to about here. So we'll call that a 120-degree angle. So I've ended up there. The radius of the lake is 5/4 miles, and I want to know how far I walked. Or you. How far did you walk? I ended up here, started here, I have a radius of 5/4. Okay, let's do this in a couple of steps. If I walked 120 degrees, 120 degrees out of the total 360 degrees is 1/3 around the circle. So I walked 1/3 of the way around the lake. Okay. It's probably back up there. That's okay. About 1/3 of the way around the lake. All the way around is 2 pi. So I walked 1/3 of my 2 pi angle measure around the lake. But my radius is 5/4. So I have to account for that because my 2 pi is all the way around, but I have to multiply by 5/4 because that is my radius length. So 1 1/4 radii around. So if I multiply all these together, 2 5s are 10, 3 4s are 12. My pi stays on top. That reduces to 5 pi over 6. That's how far I walked. This is miles. 5 pi over 6 miles is how far I walked. I went 1/3 of the way around a circle whose radian measure around is 2 pi. My radius is 5/4, so I ended up with 5 pi over 6 miles is how far I walked around the circle. If you put the 3.14 into pi, multiply that out, you'll see 5 3s are 15. You walked whatever that turns out to be in a decimal form. And that's how far you walked around your circle. What we're going to look at now is radians and degrees together. So we're going to take angles in radians and change them to degrees. And then we'll take angles in degrees and change them to radian measure. So I'm going to put an arrow that goes both ways. So let's start off with degrees. If I take a 45-degree angle, nope, not that way. Let's start off with a whole circle. A whole circle we said was 2 pi radians. And it was the same as the whole circle as 360 degrees. Well, this is an equation. They measure the same angle inside all the way around. So let's divide both sides by 2, and I get pi radians is the same as 180 degrees. And we have already seen on a circle that an angle of 180 degrees, if you start on the positive x-axis, ends up on the negative x-axis, so that's your 180-degree angle. So this is the part we usually use when we're transferring back and forth between radians and degrees. So let's take that 45-degree angle. Now, since this is in degrees, I want to make it radians. So I'm going to multiply by whatever I need to multiply by to get rid of degrees and make it radians. So I'm putting degrees on the bottom, so my degree measure units will cancel. So it's pi for every 180 degrees. So the degree units will cancel. This is pi radians. And so this angle in degrees is equal to 45 pi over 180 radians. That's kind of messy. But you'll actually find out that 45 divides into 180 4 times. So this angle is the same as, that's a funny pi over 4 radians. So 45-degree angle is the same as pi over 4 radians. How about an angle in radians? Let's take pi over 3 radians. And since it's in radians, I'd like to change it to degrees. So I'm going to take this and multiply by something that will cancel radians, which would be pi. So in the bottom is pi radians, and on top I'll have 180 degrees. And that's how I will get rid of my radians. The radian units cancel. And on top I have 180 times pi over 3. Whoops, not times pi. I just said my pi. I didn't say my pi cancels. I said my radians cancel, but so do my pi's. So all I have is 180 degrees over 3, which gives me an angle of 60 degrees. So a 60-degree angle is the same as pi over 3 radians. Let's go a little bit more complicated here. Let's take an angle of 5 pi over 4 radians. And if I want to change that to degrees, I multiply it by the pi on the bottom for radian measure, 180 degrees on top, and then you would multiply, after you cancel, 5 times 180 and divide by 4. So that would give me an angle measure of 225 degrees, 5 pi over 4. It's also 5 times the pi over 4 angle. Well, the pi over 4 angle was 45 degrees. Is that pi over 4? 225? Yeah. 5/4 is 1 1/4. Pi over 4 was 45 degrees and multiplied by 5. Gives me 225 degrees. So that's another way you can think of these if you want to. Your pi over 4 angle is half of pi over 2. You will see radian measure a lot using pi's, so try to get accustomed to the notation with it. It's really not that bad after you practice a lot. So do the examples in the lessons to practice too. Now, radian measure does not have to have a pi in it. Suppose I take 27 degrees, and I want to change that to radian measure. Well, I want the degrees to cancel, so the 180 degrees goes in the bottom, pi radians goes on top, and I end up with, canceling my degrees, I have 27 pi over 180. You could try to reduce that fraction. It actually would divide 9 into both pieces. You could do 27 divided by 180, and that would give you 0.15 pi radians. But if you're going to a decimal, you might as well take the pi and make that a decimal. So if you multiply 27 times pi divided by 180, there's a pi button on the calculator, you actually end up with a decimal that if you round it to 2 decimal places is about 0.47 radians. And so this is a real number. There's no pi in it. It's just a number. And we will be doing a lot of our trig using Radian Measure that doesn't have pi's in it necessarily. It just has a real number as the value you're using.